Seriously, is Andy in the room?
Nope, I'm not Amy.
Small assignment? Yeah, it doesn't take long. It'll take like 10 minutes.
There we go. Okay. And I want. Let's go. There we go. Okay, so we were talking about curvatures of the spine. We're talking about how the spine is constructed, and we have all these fun, heavy things. I'm going to leave it off the full presentation because I'm going to switch back and forth so I can poke and prod and put all my happy new toys with my friend. So that's that. Let's go over to the column.
Yeah.
Okay, so if you could kill some front lights for me so I can show this guy. So what we have, so I can try to show my happy little spine here. What are the names of the curvatures in the spine? What are my regions? We'll start there. What are the regions of the spine? Cervical, thoracic, lumbar, sacral, coccygeal. Thank you for finishing that off for me. Now, can you remember how many spinous process, how many vertebral bodies are within each?
30 something. Yeah, 30.
So in through here, we've got 7 that sit for the cervical spine. Right? Thoracic. Thoracic. 12. Good.
5.
Lumbar. 5. Sacral.
5.
5. Coccygeal.
3 or 4.
4. Good. Really? Hey. No. Oops.
It's like 3 servings.
Okay. So, directions that we have. What are the 2 types of curvatures that we have in the spine? What are the names?
The abnormal ones?
What?
Lordosis?
Kyphosis, lordosis. Those are the happy trigger words I'm looking for. So, which is which? Where do we have?
Butt sticks out on lordosis.
Where do we have lordosis?
The bottom curves out.
So,
More concave. Recumbent.
lordosis for sure. We have the easiest part that things people remember is this section down through here. This little curve right through there. Right? Okay. Where else do we have lordosis? Where? In the cervical. So I have that little curve right through there. Same kind of idea. It's a concavity, so it caves in, right? So that's going to give us kyphosis predominantly through our thoracic spine, and then again, sacral down to coccygeal.
Good. I didn't know that.
Good? Okay.
I thought it was just the bottom.
Now, that changes throughout our lifespan. Now, as a fetus, when we're first born, it's nice, one big, happy kyphotic curve, and everything's nice and simple. Everything's easier when you're a kid, right? Somebody's feeding you, don't worry about a job, even your curve is all one big curvy piece. So as a newborn, we start getting a little bit of a lumbar curvature back through here, and as we hit 4 years of age, then we're fully upright and walking a lot, and our body starts adapting to that uprightedness, and then it's fully progressed once we're adults. So it changes over time. Now, stability, decreased range of motion, and flexion extension, especially between T1 and T6. So we talked about this increase in strength that we've got in the thoracic cage. Why do we have a decrease in strength, a decrease in motion, increase in strength in the thoracic cavity?
Fusion.
Yeah, we don't want our organs to go squish.
And respiration.
So what else supports that? What else stabilizes that?
Ligaments.
Ligaments.
Tendons.
What's unique for the thoracic cage, though? What makes the cage part of the cage? Ribs. So they help come around and create this bony junction that stabilizes things. Now, it's not solid bone, there's cartilaginous pieces in there because we want it to have some give. So, ribs, 12 total pairs, 7 true, 3 false, and 2 that float down here at the bottom. And they help protect our organ structures. They go from vertebrae T1 through T12. Now, superiorly, the top ends. Go away. Cage. And ribs. So we have ribs. So superiorly, if you look at these guys, there's a significant difference you can identify with the first rib. It's broader, it's fatter. It's very strengthened for the stability. What goes underneath it and underneath the clavicle?
Muscle. Wait, what was the question?
Why is rib number 1 different?
The nerves.
I hear lots of shoo, 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 which is what my daughter does when she's not sure the answer to. So that's fine, but get your voice out there. Why is the first rib different?
Does it help with muscle attachment and the breathing mechanism?
We've got some musculature in there that hits most of those bones as well. The intercostal muscles go in between most of our ribs, would help expand the thoracic cage in and out.
Does it support the clavicle?
So our clavicle is going to sit
Or above it?
pretty much right on top of that. When you can feel clavicle and underneath deep, you can feel
Does
that
it help
first
stabilize
rib.
it?
You've got your eyes poke across. Come on now.
Ooh.
So why do we need to have it stabilized? Why is the first rib different?
Cervical?
Muscular attachments from on up. The platysmus coming down. Reinforced strength if you take any kind of hit from above because it's more exposed. What's immediately underneath the clavicle on the first rib?
The lung?
The heart's there. What comes off the heart that we care about? I don't know, an aorta maybe, carotid artery.
The veins?
There's a lot of vasculature. The brachial plexus comes down into that region, right underneath, tucks in. So if we've got issues, that's helping deflect those away from that soft structure underneath. It's not as likely you're going to get a direct blow coming at you here as it is coming at you from the top. And so your clavicle and your first rib really help support and reinforce that structure. So, ribs, the articulation points. Let's talk about vertebrae for a second. So, vertebrae, we're going to back off just a little bit. So, vertebrae, we discussed the differences between them. There's some unique components about each of the different shapes, about each of the different components, different regions of the body. They look a little different. T1 looks a lot like T7. We focus on T6, which is kind of the mid-range of it. You're going to see that we've got articular facets that are almost vertically aligned, which is, again, as it interlocks here in a superior articular process of the inferior, it creates kind of a lock mechanism so that they can't shift too much, which, again, adds to that stability of a decreased mobility but lots of strength within the system. And the spinous processes are pointing almost directly inferiorly as well. So because they come down almost directly on top of one another, it's limiting the capacity for that rib section, for the vertebra section, to lean back. It limits how far back it can go in extension. So again, adding to the stability of it. The vertebral bodies are somewhere in the middle between the cervical, which are very small but non-existent, and the lumbar, which are very massive. Your typical ribs through this area have 2 facets. They have 2 articulation points. From the 3rd to the 9th, they'll articulate with the vertebral bodies above and below. They'll have the capacity to shift up and down, to rotate. So it's not quite your synovial joint. It can actually shift, and you can actually dislocate those ribs as well. Your first rib is nice, broad. Grooves for the scalenes come into the top edge as well. So we have points of muscle attachments, but again, you can see that it's a much, much fatter, much broader, much stronger. The second rib begins to look like all of the others. But it's only going to have one articular facet for in the posterior connection as well.